Hello and welcome back. In this video, we're going to take a look at question number 9 from the Applying Newton's First Law and Second Law practice. Number 9 says, two masses are connected by a string and are accelerated vertically upward. Let's take a look. In question number 9, your picture should look like this. If you have not drawn the picture, pause the video right now and draw the picture. Now that you have your picture drawn, let's take a look at what we see. The first thing I would notice is that there's two ropes. So I'm going to make sure I identify them in terms of what's going on. I'm going to call this rope 1. I'm going to call this rope 2. Now, what I like to do on the original picture is draw kind of a sketch of some of the basic forces that are involved. I know that on mass 2, we have weight 2, which I'll label as M2G, and I have tension going up the rope. Now on mass 1, I also have the same tension going down the rope because that rope pulls on mass 1 from below. But I also have M1G, which would be the weight of mass 1. So I have two forces going down from mass 1, whereas only one force going down from mass 2. I also have tension going up the rope. Now, since this is rope 1, I'm going to call this tension 1. Since this is rope 2, I'm going to call these ones tension 2. Remember, same rope, same tension on this one. Different rope, different tensions. Hence, we are labeling 1T1 and 1T2. So I should expect 3 forces to be labeled on mass 1 and 2 forces to be labeled on mass 2. Let's take a look at our free body diagram. Our free body diagram is now an opportunity to make sure that the forces are drawn relatively to scale. That means any forces that are supposed to be equal should have arrows depicting the force vector magnitude as being equal or the same length. If an object is accelerating, then we need to draw one force vector longer than another force vector in the opposite direction. Let's take a look and begin with mass 2. First thing I'm going to do is I'm going to draw an arbitrary length for M2G. But I'm going to draw the tension a little longer. In fact, just for being able to work this, I'm going to draw these a little shorter. There we are. Okay, so that's mass 2G. And again, notice, guys, I'm making tension 2 longer than weight 2 because I'm accelerating upwards. Okay, whatever your causing force is should be longer than your opposing force. Then I'm going to take this same length of tension right here, but I'm going to apply that downward on mass 1. So tension 2 applies downward on mass 1. And I also have weight 1 directed down as well. M1G. So notice I have 2 forces acting down. I need to draw tension 1 long enough so that this arrow is longer than the combination of this one and this one, so that the forces going up are greater than the forces going down. Why? Because I'm accelerating in that direction. Now, let's take a look at the overall system. So the system, when we're dealing with the system, we only look at external forces that cause or oppose acceleration or balance each other out. What we don't look at is we don't look at the tensions in the middle of two masses. So I'm going to ignore tension 2 for this particular discussion. My external forces would be tension 1 because it's causing acceleration upwards of the whole system, and weight 1 and weight 2. Those are my causing and opposing forces. So let's identify them. Tension 1 is a causing force. Weight 1 and weight 2 are opposing forces. And so if we apply Newton's second law for the system, causing force minus opposing force equals sigma MA, causing force would be tension 1, minus, well, you have two opposing forces. You have weight 1 and weight 2. So I'm going to subtract both of them. Minus M1G minus M2G equals sigma M means add up the masses. There's two masses. Mass 1 plus mass 2 times acceleration. This would account for the equation of the entire system in order to help find the acceleration of that system.